Math Practice 2.
Reason Abstractly and Quantitatively by Hailey
and Brittany Richardson. So why should we reason abstractly and quantitatively? Well, quantitative and abstract reasoning are in our everyday lives. Quantitative is the ability to apply math skills and concepts to solve real problems. This could be problems like understanding things that we read in newspapers, working on certain financial decisions that we have to go through every day. Also, it could be in analyzing advertisements. But we have to go beyond just the ability to compute. To solve math problems, abstract reasoning is always necessary. If you have a word problem that states, Jim had 4 apples and he ate 3 of them, how many apples does he have left? You have to be able to abstractly think of that and pull it into an equation. Also, why do we need to understand this standard? Is because this standard connects with Math Practice 1, which is making sense of problems and persevere in solving them. When you're reasoning something, you're making sense of the problem and trying to understand where it's coming from and what do you need to learn out of it and what do you need to pull out of it to make the correct equation and get the correct answer.
So, understanding the standard. When teaching students about Math Practice 2, they need to be able to understand that there are different quantities that can be shown in a variety of ways, and they need to know how these come about. They also need to be able to represent word problems in numbers, symbols, diagrams, equations, any abstract form, as well as they need to be able to take these equations and numbers and symbols from their abstract forms and put them into word problems. And then after that, you need to teach the student how to connect these equations back to their word problems, or vice versa, taking the word problem and connecting it back to the equation. This chart that we found online basically shows you reasoning abstractly and quantitatively. It shows how, on the left side, how you can take the numbers 26, 27, and 53 and put them into a word problem that the students would have to solve for themselves or come up with for themselves. And on the right side, we see words to numbers, where we take a word problem and take the numbers of 26 boys and 27 girls and try to figure out how many children are on the playground, coming up with the answer of 53. Your students would have to be able to understand that the 26 boys and the 27 girls need to go together so that you can make the 53 students total.
So this is an example of putting the problems into abstract forms. Our problem is that Joe had 8 cookies. He gave Amanda 3 cookies, and how many cookies did he have left? Well, you can have your students represent this in many different ways. There's many different abstract forms that you can use. The one that we actually used to represent this problem was that we had 8 circles. With the 8 circles, the students could then either take 3 of them away, erase 3 of them, mark 3 of them out. You could actually have them do it on a dry erase board, and they can erase the 3. I mean, there's many different ways that you can do it. On this one, we just took and marked the 3 out. So that way it showed that he had 5 left. Like I said, this would be a great way to show your students, the many different abstract forms and taking a problem that's written in words and putting it into an abstract equation that they can actually manipulate for themselves and understand better.
Okay, so now we're going to talk about contextualizing and decontextualizing a problem. Decontextualizing is when you take the information that you've gotten from a word problem and correctly putting it into an equation, which would be you want to add when it says how many do they have together and not subtract. You have to make sure that you have the right equation for the information. And then contextualizing is taking this equation and putting it back into your word problem and noticing that your answer is from your equation. And then when students are doing all of these things, they have to realize that in some instances you're not going to come up with a realistic answer, so you're going to have to either round up or down to your nearest whole number.
So this is another poster that we found that is for Math Practice 2, Reason Abstractly and Quantitatively. This actually talks about the contextualize and decontextualize that Hailey was just talking about. Contextualize for students is, like she said, whenever they can take the numbers and put them into a real world context. And then decontextualizing is taking the numbers out of the context and putting them into an equation so that they can solve it. Also, this is a poster that I would probably put up in my classroom for students to look at. They may be bigger words that they may not understand, but that's something that you guys can talk about, and it would be an example of them taking an equation and putting it into words, or taking a word problem and putting it into an equation. And I think this would honestly help quite a few students.
This is our example for decontextualizing and recontextualizing a problem. This is great to use in your classrooms when you're trying to explain to your students how to do these problems. Our problem is 120 students and 5 chaperones went on a field trip. Each bus held 35 people. How many buses were needed? The first thing you're going to do is you're going to explain to them how to decontextualize this problem. You would explain that you got 125 people, but only 35 people would end up on one bus. So you have to break these people into 35 people groups. So you're going to take 125 and divide it by 35, and you're going to get 3.571. This is the point where you would explain to them how to recontextualize the information and explain to them that this answer is not realistic. You can't take 3.571 buses on a field trip. You'd have to help them recognize that you'd need a whole number, and this would cause you to round up to your nearest whole number. Therefore, your answer would be you need 4 buses for this field trip.
So, how do we get there? How do we help our students to develop these important practices? Well, there are many different techniques that you can use. Many of them have been tested. You can actually find more on Pinterest. Pinterest is absolutely amazing. However, a few that I have listed here, I've got number webs. Number webs is when a student is given a certain quantity and they have to have, it looks like a little spider web, and out on each branch it has different ways of getting to that quantity. It can be represented in fractions, in whole numbers, and half numbers, in with decimals, with little blocks, percentages, many other ways. Also, another way was to focus on the question. Focus on the question was actually mentioned in Math Practice 1, but focusing on the question is actually when you're taking the word problem and putting it into an equation. That's pretty much it. You have to understand the word problem to be able to put it into the equation. Another way is actually headline stories. This is the problem that you guys are going to be doing with headline stories. Pretty much you just take an equation and then you have to write your own word problem to it. Students can have many different word problems for the same exact equation. Also, like I said, there are many different techniques out there. I would go on Pinterest. You can Google these things all day long. And I mean, they're great techniques. Thank you guys. Here's our resources.
Hope you really liked our presentation. Bye!